So, good day everyone. So, for today I will be presenting my report. It's all about the pattern interpretation. So, what is a pattern interpretation? It is all about naming a pattern. Next is the whorl pattern. About 35% of all fingerprint patterns are whorl. So this type of pattern is next frequency of occurrence to the loops. The plain whorl. A plain whorl is a pattern in which there are two deltas and at least one ridge making a complete circuit, which may be spiral, oval, circular, or any variant of a circle. An imaginary line drawn between the two deltas must touch or cross at least one of the recurving ridge within the inner pattern area. So meaning to say, in the plain whorl pattern, there are two deltas facing each other, which is here. So we can see there is a delta here, the pattern area, and the delta, and the other side is here. We can also see a delta that face each other here, this one. So they are facing each other, so as if there is a imaginary line there, and the requirement is there should be one ridge making a complete circuit, which is touch at least one of the recurving ridges within the inner pattern area. So the imaginary line here, there should be a recurving ridge, at least one, that will attach at the imaginary line. So sorry for not clear image, but as if it is already discussed with Sir Dolores, so is part of a review of my report. So that is the plain whorl is there should be at least two deltas or one ridge that complete a circuit. So some plain whorls look like bullseye targets where there is a series of circles or ovals. Others look like clock springs which have unwound to the right or to the left. Whorls exhibit various shapes around the core, such as round, oval, or almond shape. It is essential to remember that the outer boundary of the whorl consists of two deltas instead of one as in loops. So that's what I have said, there should be a two deltas. So shows the two deltas in plane and in the pattern ridges have been filled in. However, the two deltas may not necessarily be at the same type. So as an example here, there are two deltas facing each other, and here there is a imaginary line, and there is also a one ridge, recurving ridges attached at the imaginary line. In plain whorl, an imaginary line drawn between the two deltas must touch or cross at least one of the recurving ridge or circuiting ridges within the pattern area. So the dotted line represents an imaginary line drawn between the deltas, since this imaginary line does not touch or cross a whorl type ridge within that pattern area. The pattern is not a plain whorl, since it possesses two deltas It belongs to the whirl family known as central pocket loop whirl. So, let's proceed to the central pocket loop whirl. A central pocket loop whirl is a pattern which has two deltas and at least one ridge making a complete circuit, which may be spiral, oval, circular, or any variant of a circle. An imaginary line drawn between the two deltas must not touch or cross any of the recurving ridges within the inner pattern area. The technical definition of a central pocket loop whirl is somewhat complicated since it combines features of both loop and plane whirl. It is a pattern which for the most part looks like a loop, but which has a small whirl inside the loop ridges. Sometimes it is referred to as a composite pattern because it is made up of two patterns in one, a whirl inside a loop. It has two deltas, one which appears at the edge of the pattern area, as in a plane loop, and one which shows inside the pattern area just below the centermost ridges. So meaning to say, a central pocket loop is there is also a two deltas, but unlike with the plane whirl, the recurving ridges must attach at the imaginary line. However, the central pocket loop, there should not a recurving ridge attached at the imaginary line here. And as you can see, there is a one delta here, and the type lines are the type lines that diverge, and the other side is here. So they are not perfect facing by each other, unlike with the plane whirl that is a line, and the central pocket is the other delta found is at the nearest of the loop of the whirl, here. We can see here the other side of the delta. So that is the difference between central pocket loop and plane whirl. So remember that in a central pocket loop whirl, what is required is at least one recurving or whirl type ridge below the core to form the pocket in the center of the pattern. It is important here to recall the difference between recurving and converging ridges. So a recurving or obstruction ridge which has an appendage connected within the line to flow and on the delta side cannot be constructed as a circuit. An appendage connected at that point is considered to spoil the recurve obstruction on that side, to be interpreted as a central pocket loop. Whirl a pattern must have at least one recurve. Remember, one recurve or obstruction ridge free of any appendage at the point of intersection with the line of flow. So conversely, in a central pocket loop, whirl is drawn between the deltas must not touch or cross any one of the recurving. So that is what I have said earlier. Must not touch or cross any of the recurving ridges. This is one way of differentiating between plane whirls and central pocket loop. Next is the double loop whirl. A double loop whirl consists of two separate and distinct sets of shoulders and two deltas. One of the loops surrounds or overlaps the other. Besides the two loop formations, a double loop whirl must have two sets of shoulders, one for each loop. There are two deltas in each double loop whirl because of the presence of two loops in each of these patterns. These are sometimes called as composite patterns. This term, like the use of it for central pocket loop whirl, arises from the fact that these patterns are a composite or combination of two in one. So here are the example of double loop whirl. So they are composite. Here the example, composite to each other, and there is, so we all know what is the shoulder of the curving ridge. So let's continue. The two loops may be connected by an appendage. So we can see an appendage here, this one. Does not spoil the recurve. That is, if the appendage abuts onto in either one of the loops at right angles between the shoulders, that particular recurve is spoiled. Just like with plain loops, if however the appendage flows off smoothly, then the recurve is not spoiled. The two loops in a double loop whirl need not comply with all requirements for a plain loop pattern, in that no ridge count is necessary for both loops in the former. The two loops do not have to be the same length nor or the same size. All that is required is that there be two separate and distinct loop formations, two set of shoulders and two deltas. So the requirements of double loop whirl is there should be a separate distinct loop formation like this one and this one. So it is not necessary that they are the same size, as long as there is two loop formation and two sets of shoulders and two deltas found. So let's proceed to the accidental whirl. An accidental whirl is a pattern consisting of a combination of two or more types of pattern, with the exception of the plane arc, with two or more deltas, or a pattern which possesses some of the requirements for two or more different types. An accidental whirl pattern looks like a conglomeration of ridges. It does not abide by or come under the definition for any of other pattern types. Whenever a pattern has two deltas which does not conform to the rules for plane whirl, central pocket loop whirl, or double loop whirl, the chances are it is an accidental whirl. So here are the key points, the keywords. So whenever a central pattern has two deltas which does not conform to the rules for a plane whirl, a central pocket loop whirl, or double loop whirl, so the chances here is it is considered as an accidental whirl. So here are the example of accidental whirl. So it is not So as what you can see is it is different from plane whirl, double loop whirl, or central pocket loop whirl. We can find here a tented arc. This one, a tented arc. That is the one that we can identify that it is a accidental whirl. We can see an tented arc, and it is not form a loop or a wall. No, it is difference. The pictures emphasize that we can identify that it is a accidental whirl. And now let's proceed to ridge tracing. The term ridge tracing is applied to all whirl type fingerprints. All patterns of the whirl family are given ridge tracing. The technique of whirl tracing depends upon the establishment of the focal points, the deltas, when the deltas have been located, the ridge emanating from the lower side or point of the extreme left delta is traced until the point nearest or opposite the extreme right delta is reached. So, what is ridge tracing? Ridge tracing is the process of tracing the ridge that emanates from the lower side to the left delta toward the delta to see where it flows in relations to the right delta. The boundaries for ridge tracing in whirls are the two deltas instead of the core and delta as used in loop ridge counting. So I have here an example picture. So the boundaries of the ridge tracing is the two deltas. So here is the other side of delta, and the other side of here is also a delta. So to trace a whirl pattern, first locate both deltas. So this one. Place a pencil or ridge counter exactly on the left delta. So sorry for the example I have given. Is not appropriate. It is for the rules of ridge tracing, but and for the imaginary. So I will proceed here. So this one, and not this one. Okay, let's use this one. So place a pencil or ridge counter exactly on the left delta and trace the lower branch of the delta over toward the right delta. If the ridge being traced ends abruptly, drop to the next lower ridge and continue the trace on it. Should be trace ridge bifurcate, follow the lower branch or forks of the bifurcation. Meaning to say, so here is the delta, the other one is here delta. So the delta is not counted anymore. So let's start here, this one, the ridge tracing, and also here the delta over here is not also counted. So let's start ridge tracing here, here, and here. So never begin the trace on a type line. Also, what I have said is the divergence area. Here, never begin here. This one, divergence. The trace is always begun exactly on the left delta. Sometimes the left delta will just be a ridge dot, as just deltas are sometimes formed in loops to begin the trace. Start on the dot and then immediately drop down to the first ridge below. If the first ridge trace, start on the dot and then immediately drop down to the first ridge. So that is all. And for the rules of ridge tracing of Burroughs fingerprint is, rule number 1 is choosing deltas. Rule number 2 is when ridges abruptly end. Rule number 3 is when delta has a dot pattern. Ridges abruptly end. Rule number 4, when ridge bifurcation appears. So bifurcation, choosing intervening ridges. So that is the end of the show. So that's all, and thank you.